So we are going to talk tonight about what observability is, what observability does, and why observability, hopefully, should matter to you. And before we do that, yay, we're going to talk a little bit about me so that you know why you should or shouldn't listen to me. I'm Cory Watson. It's very nice to meet you. I really should put my how to see me on here, but it's on the last slide. So if you're interested in keeping up with stuff I'm up to, my tweeters and my websites, they're all at the very end. So stick around for that, I guess. Should have put it at the beginning, but I work for a company called SignalFx, which, disclaimer, sells observability stuff. So that's probably the last time I'll mention that, but I am a little biased. But before that, I was also a customer and have been a practitioner, as we'll discuss in the slides that ensue. So I have been computering professionally for a little over 20 years, so I've been doing this a long time, and I've pretty much carried a pager for that whole time. Like at one point, actually a literal pager that I actually had on my pocket. Not my phone, which was pretty cool. I got my start doing dial-up ISP tech support in rural Tennessee. So Windows 3.1, Trumpet Windsock, dial-up modems, that kind of stuff, helping those folks get their computers set up, which was exciting. I also live still in Nashville, and I have worked remotely there for pretty much my whole life, or for some companies there, but a lot of Bay Area companies lately I've been working remotely. So if you want to talk about remote stuff, I like talking about that too. So some past life stuff I already mentioned. I started in tech support at a dial-up ISP. I was an SRE at Twitter working on message queues, then later an SRE on the observability team, then later managed the observability team at Twitter, and then did a stint at another place that I'll talk about in a minute, and then principal engineer. Stripe doesn't really have titles, but the closest thing would be a principal engineer, and I started and ran the observability team in my time there. So a little more about my experience. This is important for context, right? Because depending on where you are at the company that you work for and sort of what that context looks like for you, we need to know what the context I'm speaking about is. It's easy to get up here and say, when you work for a company with thousands of employees, you have all these resources. Well, I was also the 15th hire at a small startup. So I've sort of run the gamut. I've kind of done that on purpose. Each of the companies I've joined was primarily a choice about size and experience, so I could sort of learn what it was like to be at a company at that stage. At Twitter, I joined around 1,000 people in 2012. I was there for about 2 years. Keen.io is a small startup that did analytics, and I was the 15th hire and left at about 50 people. Joined Stripe at about 250 people, left in December of last year at about 1,500. At some points, the team that I worked on, the observability team, was not a team. It was just me talking to people about observability and having them ignore me. And then at other times, it was dozens of people representing some of probably the most expensive team at the company sometimes in terms of the volume. We'll talk a little bit more about that later. And I've also worked at companies with like 100 machines up to companies with hundreds of thousands of machines. So the point is, I've seen some shit. And so I have some fun stories to tell about some of that. Twitter on-call stories can be really fun too. All right, so observability is what we're here to talk about tonight, and we're talking about demystifying it, making it something that's relevant and useful to you, talking about what it is instead of just a cool word that people use when they're trying to sell you something, which is also still kind of true. But what is it? Why do you care about it? What are its parts? How can you get started with it? What are some practical ways you can use it? And what are some next steps that you can go into after you hear me talk about it? So, step one, what is observability? This talk was a little longer when I dry ran it yesterday, so I cut some slides out. I'm going to skip some of the old back matter that you can get from Wikipedia if you look up observability, and instead talk to you pretty directly about what it is today. Observability's got backgrounds in engineering. Any engineering majors in the house? Did you do a control theory class? PID controllers, closed feedback loops, that kind of stuff makes sense to you? That's where observability comes from. We're not going to talk about that today, though, because that's not really what we're doing with it when it comes to computers. When it comes to computers, what we're talking about is an attribute of a system. We talk about systems being scalable. We talk about them being performant, reliable, safe, all these other things. Observability is an attribute of a system. It's not something that you can just put on with a can of paint. It's something that you can measure and that you can add to a system with work. It lets you ask why for things that you didn't know you were going to have to ask at the beginning. So you don't necessarily know at the beginning of a project all the things you're going to need to measure. So we need to put sensors in places to help us see into our applications. The things that we build are really complicated. You know, when we started off with software, it was like you could sort of get it all in your head and you can understand it, but nowadays we've got Kubernetes and service meshes and service netties and Mercedes. I don't know. There's all these crazy things that we have to like sort of strap together to convince them all to work. And we need some way of instrumenting them to understand what they're doing. So being able to see into these systems, we're using that in a sort of like figurative way, but being able to see into them means that you can probably figure out what's wrong with them because you've got these sensors and this instrumentation. You can also, importantly, this is something I think we look over a lot because we tend to talk about incidents, you can also validate hypotheses. Not just something that's wrong with the system, but also something that you want to change or improve or something to that effect. And this is also, importantly, how we're going to debug the inevitable failure of your system. I know you're saying right now, Cory, my stuff's never going to break. I promise you it probably will, and it will be when it's very inconvenient. I have to turn and rudely look away from you and make sure that the slide changes, and also because I don't memorize these slides. There we go. So this is my definition of observability, which I'm going to boringly sort of read, but I know you're doing that too. So observable systems, again, it's an attribute of a system, are systems where operators have improved ergonomics and information for investing and diagnosing behavior. So again, an attribute of a system. It is observable if the people that operate it have good ways to look into it and understand how it functions. Observability, if we add the ility onto the end, is a raft of techniques all strung together and tools that aim to improve the understanding of complex systems. So observability is about the tools that we're using to be able to see into these systems and do stuff with them, because you're not physically looking at them and you're not reading the sensors yourself. You're sort of amalgamating all this data together and presenting it to you or to your users. And then lastly, observable systems paired with observability tools allow operators to more quickly grasp the impact of changes, not just incidents, but changes, and the nature of incidents. So observability often gets described as a bunch of things. We often use that Wikipedia definition that I'm sure you'll find if you look it up. But at the end of the day, it's a combination of being able to see into systems and the tools that you use to do that so that hopefully you understand them better and can use them better. So why should you care? That's cool. I saw some nods. I'm glad some people are already on the same page, but maybe some of you are like, well, that's great. Why should I care about this? Well, you should care, first off, important public service announcement. It is not possible to enumerate all the ways that systems are going to fail. You cannot right now say, you know what, I'm going to think of every single way that this service or this application that I'm making or whatever it is going to fail. Failure has this really annoying habit of just coming up with entirely new ways. It's like users. We keep coming up with new and interesting users. Same thing happens for failure. A benefit of observability is that because your system is observable, you are more prepared when this failure happens, that you're more likely to be able to see into it and be able to do something about it. And notably, we don't care so much about the causes of these things because, again, we can't see all the causes. We can't enumerate every way that that client library will fail to connect to Redis or every way that that Redis instance is going to fail, but we can measure the symptoms. Particularly, we care about measuring the user-facing symptoms because those are the things that are the most important. And these measures ultimately sort of become your business for reasons that I think is on some ensuing slides. Also, we're going to help future you. Current you is pretty smart. Future 3 o'clock in the morning you, also smart maybe. 6 in the morning is better than 3, but we're trying to help future us. And you can be prepared, and with better instrumentation, we're going to do that. So think about future you. There's that old adage about something that if you write the most fancy code you possibly can, there's no way you can debug it. Similar for observability stuff. So what are the parts of observability? We've talked about what it is and why you care about it. We care about future us. We care about being able to see some of these really important parts of the business. So all these words are going to make some sort of sense to you. You've probably heard them all before, and you probably know these things, this whole 3 pillars of observability: logs, metrics, and traces. This thing's on wheels. That almost was really bad. I was just going to lean on it hard. All right. These are the pillars that sort of hold observability up as a practice. And it's important that these different tools play nice together, these different sources of information. And we're going to talk about all of them individually, by the way. Maybe. So the print statement is how we usually get started with logs, right? I'm sure none of you debug with print statements, do you? How many of you wrote code at some point in your life that says got here in your code because you were debugging? How many of you did it today? Yep. That's a thing. You did it because it gets the job done. And it works really well. It's really simple. Very low friction, super easy to get results for it. So pretty soon you're like, okay, I printed got here. And then after a little while, you're like, well, this is getting kind of complicated. I'm doing a bunch of stuff. I better print out something like, I don't know, database query to get customer information took 123 milliseconds. And now you're doing this thing where developers talk to themselves in the logs. And things start to get pretty real after that. Soon, you end up with this thing at the bottom, which everyone probably knows how to read if you've been doing this for very long. This is like some application at info level in its main function at this certain time, at this line of code, operation took 123 milliseconds. This is pretty basic stuff. Everybody knows this. So logs are pretty great. But how can we do, like, how do you do logs? How do we do a better job of this? First off, don't write another logging framework. I was reading an article today that said that, and I highlighted it and put it into Instapaper. But the important thing here, and the reason that I wanted to skip onto this slide and not spend a lot on that last one, is you should structure your logs very quickly. Don't just start doing print statements that talk to yourself. Think about being able to emit it in a structured way. I wrote a note to myself yesterday that said, put an example of a structured log on this slide, and then didn't do it. But on the last slide, we saw, you know, there was some data here, like database query took 123 milliseconds. Why is this not structured in like a JSON structure, right? Or why is it not at least key value pairs or something to that effect, right? You need to put this information in there so that you can pull it back out again easily. Nobody wants to start writing a bunch of regular expressions to parse your log files. We've all done that. That's not fun. So very early on, put yourself into structured logging, and that way when you do use your logs, they're much more effective as a source of information in the future. Also be prepared for sampling. You think that logs are free, and it's like, man, I'm just doing some print statements and some log lines, and everything's great. And then before you know it, you're getting a whole lot of requests per second, hopefully, and every one of those requests logs hundreds of things, and then you've got thousands of machines, and oh my God, this costs a fortune. So be prepared for that. Now, if logs are basic and they're straightforward and they're sort of rote and we all get them, sort of like, you know, I don't know, very, very easy to grasp, then metrics are sort of magic, or sorry, science. I'm skipping to my next slide. Metrics are very sciencey. Metrics have a name, a time, and a value. So at the top here, we've got this request duration. It took 123 milliseconds, and it happened right now. That's very similar to the log line that we did earlier, except this is extremely precise and meaningful. This is something you have chosen to very specifically measure and get the result out the other side, right? So you've made a very conscious decision to do it. They are very, very efficient to store. There's a whole bunch of stuff like, let's see, deltas and run length encoding and compression things that you can do to store time series very easily. And then they're also really valuable because you know precisely what you're measuring. And unlike a log, which is often full of garbage, you've got a whole bunch of stuff in these metrics that you have very, you know, explicitly called out and put together. And they're super easy to visualize. We can see at the bottom, this was easy to put together because we have a bunch of times and a bunch of values. By the way, this is a horrible example. You should never use a area fill chart that occludes the things behind it. This is a really bad idea. I don't know why I use this as an example, mainly to make fun of myself. But they're also kind of easy to lose context of because at the beginning you may have 50, 60, and 100 metrics. You can keep those in your old noggin there and be able to call them up as you need to. But what happens when there's suddenly 50 or 60,000 of them? Are you going to be able to remember all of them and where they come from? This is a very common problem to have in large organizations because suddenly there's all these metrics and nobody knows what they mean or how to find them. So metric libraries, these are out there. They're pretty easy to get. I don't have to tell you what they are. Every single programming language and framework usually has something. Very easy to add timers to your code. That's usually the most common one is timers and counters. There are also tons of OSS integrations with common services, frameworks, all that kind of stuff. Like if you're building something with Rails, there's tons of metric stuff that you can just sort of bolt right onto that and very easily start to measure things, or that will automatically measure them for you. If you're making database requests or how long the request took and stuff like that. That stuff's all basically free and it'll pop right out of your application. This is also something that vendors will commonly do for you. They can say like, oh yeah, we know how to scrape stuff out of Kafka or something like that. I'm giving you these examples not because I work for a vendor, but because they're practical ways for you to get started and very quickly be able to get value out of this. And if you have a relatively small number of instances or machines, that's usually fairly cheap to do with any vendor. Now, if logs are fairly easy to get and somewhat pedestrian and metrics are science, then tracing and spans are magic because they do so much for you. So if you're not familiar with the term span, a span is a component of a trace. So a trace is like a whole bunch of things that have happened over time, and each of the things in that trace is called a span. And so spans contain some sort of name that says what they are, a time, a value, a source of where they came from, and most importantly, they have some sort of a cause. We know why this span happened because this other span sort of begat this span, and it sort of begat its way all the way down. And so here on the right, we can see this is like a request duration. It took 123 milliseconds, happened right now, and it came from a service, and then I didn't have room, but also this other service is why this one exists. Like we called this other service. And so this is sort of like a counter and a timer. It's all rolled up into one, right? By definition, the occurrence of a span is a count, and you can increment it and say that this happened. But then they also implicitly contain a time, so we know how long the span took. And they're very rich. They usually don't have cardinality problems. Metrics often have difficulties. Some of you may know that if you put too many tags on a metric, like if you try to put a customer ID, that sort of runs away from you after a while and can be sort of expensive to use. Usually, tracing systems don't have this problem. So all this information that we got in this dashboard came from just a span that we put on a service. We're able to take each, well, this is actually many services, but we've got 5 different services sort of in connection here, that API called cart, called checkout, called catalog, called refreshDB, and I think we're currently looking at the checkout service, so this one right here, and we can also see how many requests per second, what the latency was, the request rate, the error rate, and a bunch of other stuff. And this required just one span that you put on the service. It can do more if you add more things all the way down. This seems great, right? You instantly want to run out and start using tracing for all your stuff, as well you should. But the problem is it does take a little more work on your part. You have to thread it through all your infrastructure, right? If you've got these 5, 6 different services that are running, each one of them, when they call the next one, has to pass along some sort of header information. If you're using a framework like or a RPC thing like gRPC or something, there's usually some way to do that, HTTP stuff, right? If you start to interact with things like Kafka and stuff, things get a little more complicated, but usually those systems have some way of passing this information. There are lots of libraries that can help you do this, things like OpenTracing and OpenCensus, which for fans of the show know that merged recently, so yay for users, that's going to help us all out in the future. There are a lot of systems, there's not a lot of good standards, although there are standards for measuring and making spans, not a lot for wire formats to get them out. Jaeger and Zipkin are 2 of the common ones that you'll find. My team ran Zipkin at Twitter. Also service meshes help out a lot with this. If you stand up a service mesh, they often have just like a toggle you can use to say, hey, emit traces. That's good. It also is a lot of traces, and it has 2 traces for everything it does because it has to bounce through the service mesh, but that's also kind of cool in some capacity. There are many, many libraries that when you use them, tracing will come for free. So if you're talking to like a message queue or something like that, OpenTracing is often instrumented for you in there, which is really helpful because you can basically get that stuff for free. Something you're going to have a little trouble with maybe if you use tracing though is where the line is. Like when does one create span and when doesn't one? How close do we get to being a profiler versus only having the 1 span for your service? You get a lot out of having 1 span for your service, so that's a good place to start. But usually I would say like if you've got some sort of middleware, put it on all your middleware, put it on any major sort of subsets of functionality that you've got within your service, usually the best place to put the line. Again, vendors help here. In many cases, you can just sort of like install agents or maybe include libraries and your applications will automatically include tracing if you don't get it for free with some of the frameworks that you've got. So this is another place where if you're trying to get spun up quickly, vendors can usually help. So, all right, we now know what observability is. We know hopefully a little bit about why you'll care about it, although we're going to talk about that more later. Where do you start? I've told you a little bit about how you could get started, but that only says like, okay, now I've got all this observability data. What do I do with it? How do I make use of it? And how do I get some value from it? It's a lot. I will tell you up front. Having suddenly thousands of metrics and all this tracing information, it's a little bit daunting. Where does one begin? Well, my advice is if you've got a new thing that you've just started and you don't have a lot of opinions about observability stuff, you should just go use tracing. It often is the most rich. It gives you the most stuff out of the box. You saw that dashboard that I showed you, which happens to be from the product that I work on, but there are other products out there and they have very similar setups, so that's really great. If you do already have some opinions about it, and you've already got some logs, you already got some metrics, and you've already set them up, just use that. Don't worry about feeling FOMO and other people have all these other cool tools. Don't worry about that. It's fine. Just use what you got. I think I have a slide somewhere very deep in this talk that says the best observability tool is the one that you have. Because when you're having a problem or when you're trying to answer a question, it's like if you're trying to put a nail in a wall and all you've got is a screwdriver, it's better than the hammer that you left at home, right? Like at least you've got something you can work with. Same for observability stuff. You should also, though, consider that a lot of the observability data that you're working with here ultimately sort of measures your customer, right? Like a modern business often doesn't, you can't often go look outside and say how many people are in the queue to buy my thing. So observability data is often the analytic data that you, in some capacity, use to measure the business. So that is something you should consider as you're investing in these tools. You don't want to just, throw something together. You want to sort of like invest in it. So that's about the which pillar, I think. DIY, open source stuff, vendor, I'm obviously biased, but I can turn that off for a little while and talk about it. We're going to talk a little bit more about that in a moment, and I don't think I'm going to do it in this slide. So. This slide, DIY, I thought that was cute. It's pretty funny, right? Okay, great. So again, disclaimer, I work for a vendor. There are, however, some very good open source projects out in the world there. Everybody's probably heard of Prometheus. Even if you don't want to use Prometheus as a sort of like time series database and alerting system, its exposition format has been a boon for everybody because getting metrics out now is something that everybody just says, well, do you talk to Prometheus? And most everything does, so that's really convenient. Prometheus is pretty great. Influx has an open source like community option that you can run on a single node. OpenTSDB, Graphite, Victoria Metrics, there's tons of them out there. Almost so many of them that it's a little bit paralyzing. That's one of the problems with these sorts of systems. Same with vendors, to be honest, there's a bunch of them. The thing to keep in mind is that ultimately you are going to need to support this, understand the costs, and staff it in the long term. It doesn't matter if you're picking something up and it's open source, that's great. If you want to use a vendor, that's great. But realize that over time, this is something that you will continue to invest in, right? It's like when you choose a language or a framework or whatever, these are long-term choices, and you will have to sort of pay for them over time. You can build it and staff it in-house. The reason that I put this in here is not so much because I work at a vendor, because I didn't for most of my life. Most of the time, I was the observability team, and I was having to get leadership to understand why they needed to let us invest in what we were doing. And at the end of the day, usually vendors at this stage can do it for you. The reason I work at a vendor is I decided, wow, I did not want to have to go build that again at another company. And at the end of the day, this is also probably not your core competency. I used to work at a company that was a payments processor. Did it make sense for them to build models to do fraud detection with ML? Absolutely. Did it make sense for them to build their own hardware and buy a data center thing? No, not really. They had other problems. But where this falls is ultimately your call. Maybe it does make sense for you to do this. Maybe it is very closely related to your core competency. That's awesome. Do that. Do you, boo-boo. All right. The other thing that you need to pay attention to here, vendor, OSS, build it yourself in-house, whatever it is. Ultimately, this stuff is critical. This is, when I worked at Twitter, observability being down was the worst possible thing that could happen because we couldn't see what we were doing. And if you can't see what you're doing, you can't do anything. You have to stop. This is something we have to worry about as a vendor. If our stuff is down, I've heard of customers that send people home because they can't ship anything. I know at Stripe, we locked everything down. No deploys, no nothing, which stops the agility, right, and your ability to ship at the company, which is the worst possible thing, especially when you're small. So since it's mission critical, you need to staff it accordingly. If you're going to do this stuff in-house, that's great, but you need to dedicate people to it. This is not something you set up and say, cool, this is going to monitor us and make sure that we are up all the time and protecting our customers, and now I'm just going to ignore it and go work on something else for a while. It doesn't really work that way. Vendor or DIY, you will have to care about it. Subject matter experts, we can help. There are lots of people who consult for it, and you can talk to them. I'm not one of them, but you can talk to me when I'm at the vendor I work at. That's nice. But this stuff, the thing that you have to remember is that if you're, say, processing 1,000 requests a second, but you emit 10, 15 spans for every one of those requests, you're going to have to be able to run that thing at 10 or 15x what you're running your service at. And in many cases, observability will become one of the more expensive, if not the most expensive part of your infrastructure, because being able to see this is the most important thing that you do. And you don't just emit one thing for each one, right? You may think, oh, well, then I can just log it and put it on disk. Well, I'll tell you firsthand, I ran logging. The ingestion and indexing of huge amounts of logs is also expensive and difficult to do. So it doesn't really matter which one you pick, they're all difficult. And no visibility, I've already said this a couple times, equals no work. And you also have to think about how to run your observability system, who watches it. It's important that if, let's say, all your service mesh stuff goes down, does that mean that your observability stack goes down? So in many cases, the sort of best thing to do from an infrastructure perspective is to run your observability stuff outside of the rest of your infrastructure, which is why often vendor solutions are pretty good. The open source stuff also tends to stand up pretty well outside of your infrastructure as well and doesn't have assumptions about how you run it. So also easy to do. The important thing about having observability set up is you're like, all right, I've got some observability stuff. I've got these spans, I've got these dashboards. We're going to talk about how to make dashboards and detectors in a little while. The important thing about it is that it's your whole company. You need to establish a culture of leveraging observability all the time. This isn't something that you just do when you have an incident. And the reason that you don't, and I don't think I really cover this super great in these slides, but the reason is that observability is sort of the mental model of how all your systems stack up. I showed you that diagram earlier in the tracing that had all these different services connected to each other. That's a mental model. That's not exactly accurate. There's lots of things. There's switches and cables and racks and all kinds of stuff that's actually between all these services, but we're just ignoring it because we think they're just connected, right? It's never the network, right? But these tools are the mental models that you use to have conversations every single day about how your systems and services and your entire operation are set up. And that means that when you're thinking about making changes to them or scaling them or growing them or adding features, you're using these mental models, and observability helps to reinforce that all the time. So you expect that when people are working on the software, I think you expect that they would write unit tests probably, right? That's sort of the acceptance criteria, table stakes these days. And you also think that for security and for privacy. Well, observability really ought to be the same. Again, this is an attribute of the system that you're building. So are they building something that's observable? Are there measures? Is it instrumented? Do you have a way to inspect it and see if it's healthy? This stuff also can influence the design of what you're building, because I know it's very common that you'll sit down, you'll start writing something, and you'll realize, I can't unit test this. I'm going to have to find a way to make some sort of adapter. Like the common one I always think of is when you're writing anything that uses an HTTP client, you always have to be able to inject that like mock HTTP client that lets you do the request and response wrapping, right? Same sort of thing happens when you're doing observability. You'll start to build something and then realize, I can't measure it this way. I'm going to have to adjust it. And that ends up building a better bit of code, just like it does when you make a bit of code that's more easily testable. Again, think about future you. Observability is also important to be able to validate features, deployments, and other eng work. At my last company, deploys were actually connected to the observability data. So you do the deploy, and you start watching the requests to make sure that the error rate doesn't get too high. Right? Now we're leveraging it for not just when there's an incident, but also day-to-day stuff, which is really good. If we're talking about making the system a little more efficient, then you're like, cool, my hypothesis is that I'm, say, burning this much memory doing this thing. Can you show me that in the data that you have today? And then show me that in the patch that you wrote, and then put it into production, and then show me the result there? Because if you can't, why did you do it? We often sort of say like, well, we wrote a micro benchmark and it proved that. It's not good enough. We need to show it in production every day. And ultimately, this sort of works for everybody in the organization. You can even think about this from the use of a new feature that you've deployed. Like, nobody says we're going to put a new feature in and then not actually measure it and then show some analytics that said that it works. This is still observability. It's all the same stuff. So how do we choose metrics? We've got a bunch of them. We're going to mostly shift into talking about metrics for kind of the rest of a bunch of this, because most metric tools, be it Prometheus's Alert Manager or any of the vendors that make these tools, metrics are what you commonly use to build most of the dashboards and the monitoring capabilities, right? Even if you do use tracing, most systems have some way to sort of turn those spans into metrics so that you can then sort of alert against them. So if you make that leap for me, some of this will be a little easier. So the first thing you need to care about is, I've got a bunch of metrics. Which ones do I pay attention to? These are called key performance indicators, KPIs. I'm sure everybody's heard that before. I won't dwell on it too much, but for those in the room that this is a new idea, you're trying to take some metrics that represent important things about how the service functions and say, like, these are things I care about. Like, if your business is selling shoes, how many shoes did you sell? That's a KPI. It's probably not how much energy did I use on my HVAC system. That's probably not a KPI for you, so that's a pretty good way to tell the difference. These are commonly things like defects, customer satisfaction, how much money you're generating, latency. Whatever your user cares about is probably something that you care about. That probably makes it key. And these things should be built into your processes, right? You want to use these to make decisions. There's a slide a little bit somewhere else that says, like, don't get stat blind and pay attention to changing these metrics, because something could change over time. If in the future you start selling, I don't know, swimming trunks, then you also probably want to measure the number of swimming trunks you're selling and not just shoes, So be sure to keep up with your business and make sure that you're adjusting those things appropriately. And the other important thing is, I know nobody in here ever does this, but sometimes you like think of something that you need to write and you're like, yeah, we're gonna write that new service that does this or that new feature. And then before you know it, you feel satisfied because you shipped it. You sort of turn it into a Boolean. It's like we're shipping it, we made a name, like it's called Project Foo, and now we've shipped Foo success. But that's not actually a good way to operate. Did the thing fix the KPIs that you set out to improve? If you did that because you were trying to improve customer engagement or improve prices or improve efficiency, those are the things that should be driving your choices to ship. So again, KPIs are what inform that. So now that we've got some KPIs, what else can we build? All right, so there are special performance indicators that measure how well your service is functioning, the services level. So we're going to talk about 3 of these. You have probably seen all these before, and a few of you might have them right, but most of you probably don't have them correct because each of these have a very specific meaning, and we often talk about them slightly wrong. So this is the pedantic slide where I try to get you to talk about SLIs, O's, and A's in the right way. So K performance indicators? Oof, my Southern's coming out. Service level indicator is the first one we're going to talk about. So you've got a KPI, but which KPIs specifically measure how well your service is functioning? We call these SLIs because they indicate the service's level. These are things like the number of requests and stuff like that, right? These are pretty basic. We'll come back to how to choose them in just a moment, though. Thing your service does is an indicator. Now, we know what our service is doing, and we know how to measure that, but what is our aspiration? What is the service supposed to be doing? Like we can say it processes requests to purchase shoes. By the way, I'm a sneakerhead, so I'll talk a lot about shoes tonight. Instantly, I saw multiple eyes look down at my shoes. Thank you. I found 3 shoe stores on the walk over here. It was great. All right, so, oops, that was too much. No. All right, so the next thing we're going to worry about is what is our objective? What do we want the metrics to say? What are we shooting for? This is your service level objective, right? This is our goal. This is what we're trying to do. This is often confused with your service level agreement, which is your SLA. It's very different, though. Your service level agreement is your agreement with somebody, probably a customer, that says we will meet an objective or we will pay you or something, right? Maybe it lets them out of their contract or whatever it is, right? It's an assurance that your customer has that the goals that you've set are actually going to be met. So when you worry about your service level objective, you may say, hey, we want to be up for 99.99% of the time. And your service level agreement may also say 99.99% of the time. That's a little bit worrisome, by the way, because you're not giving yourself a lot of room there, but we'll talk about that maybe later. So again, service level indicator indicates whether or not the thing is doing what it's supposed to. The objective is what the goal we have set for it is, and the agreement is a legal obligation usually that we have with someone else, or at least a promise that we've made to them. So how do we choose them? What do we use for that? Well, luckily, there's a fellow by the name of Tom Wilkie who came up with this thing called the RED method. So this stands for requests, errors, and duration. RED, R-E-D. Many people, I know this has become very common to hear people talk about RED metrics. We're going to talk about some other ones that are a little less common. So RED metrics maps very well to services, things that handle requests, transaction-based stuff. Requests to your service, are they happening? That's the R. Errors, are there too many of them? This is often better expressed as a ratio against the total number of transactions you've processed. So if we received 100 transactions and 99 of them were successful, then we have a 99% success ratio. This is often what you'll see in an SLO because we have a goal that we want to have 99% of things be successful. And lastly, the D in RED stands for duration. How long did the thing take? These 3 things are things that customers care about. Can they talk to you? Are you doing it right? And how long did it take? And these can be abstracted to basically anything. They don't have to just be like request response oriented processes. You could also map this to things like people waiting in line at the grocery store, right? They get in line, that's a request. There are errors. If I don't know what happens in a grocery line when there are errors, probably something bad. And how long did they have to stay in line? So this is what SLIs and SLOs are mostly defined by. This is predominantly what you'll use for your SLIs and SLOs. And again, the thing to notice here is we're talking about symptoms. We're not talking about causes. I didn't ask you to tell me how many Redis problems you had or how many times your ASG had problems, right? Not that ASG's ever had problems, so I get kicked out if I say bad things about Amazon. So symptoms, not causes. That's the important thing to pay attention to here. We'll talk more about causes later. So there's another method that is a little more advanced, but often more important. for some things that you will care about, which is the use method. This is made by a fellow named Brendan Gregg. He works at Netflix, and it stands for utilization, saturation, and errors. So use maps really well to resources, things that you use. The utilization is the amount of time that that thing spends busy. So in a given, say, 1 second window, how much time was that thing actually doing work? That's how utilized it is. Saturation is usually represented by how many things it has waiting for it. So if it's in a queue, because we all know that everything we build is actually just a whole bunch of queues all the way down, how many things are waiting in that queue? That's how saturated it is. Errors, pretty easy. See the red method. These are a little tougher to measure. In fact, most of you, if you're running, like, say, a Rails app or something like that, you probably don't have any way to know how busy that worker was doing that thing. My last gig, we did this weird thing where we inspected the function that the service was currently running and came up with a way to measure this. This is really, really powerful, though, if you can do it, because this is a very strong input for how you need to scale. Because if you're saying oh, I need to spin up some more workers, how many do you need? We all know you're probably just going to guess, but this allows you to not have to guess. Because if you understand how utilized it is or how saturated it is, you know how to sort of spin things up or add things, or if you can deepen queues, or will more cores help, stuff like that. All of that comes from your ability to use the use method. Then also at the end, this is important to help you understand where some of the problems you might see in the red method come from. So I've got some requests, but the durations are really high. Why is that? Are they stuck in a queue? Were there no workers available? Did I have a worker starvation problem? These are all really common things that contribute to problems you will see because the use method's super good at measuring this stuff. So we've talked a little bit about how to get started here. We've talked about how to choose metrics, what we can use them for. What I've described here is actually a way to take every service all the way from your business itself. Like, you can think of red metrics for how many shoe transactions you're getting, how many people fail to get shoes, and how long it takes them to get shoes, all the way down to that individual service that you're running, maybe even that core on that one instance, and you can use all these same mechanisms to do this. I say somewhere in these slides that it's very helpfully fractal because it sort of applies all the way down the stack. But we're not just going to look at these metrics, we also need to have something looking at them when we're not around. Because optimally, we are not sitting at our computers all the time. We're out living life and doing whatever it is that people who say they do that do. I don't know what it is because I seem to always be at my computer. That's by choice, probably. But we need something to keep an eye on these SLOs and make sure that if we're not meeting the objectives that we said we were going to meet, that we're doing something about it. So key on user symptoms, this is the thing we care about the most. If you try to make things that monitor every problem that you've got, you're going to have an infinite number of things paging you, and that's usually what causes people to complain about being on call. This is a feature, again, of most metric systems. We'll skip that part. The important thing for you to know is that what you're doing when you set stuff like this up is you're monitoring known failures by definition, right? If you didn't know, you couldn't monitor them, but that's an important thing to specify here because monitoring is about known conditions, and observability is about what you do when you're trying to find that unknown reason for the thing that paged you. And again, can be fatiguing, requires effort. We already covered that. This is another method that was invented by a fellow by the name of Cory Watson. I wrote a cool blog post about it yesterday. You can go read about it. Not yesterday, Tuesday. I don't know what day it is. And so this is called the case method. And this is a way to think about monitoring and how to make monitoring more effective in your organization. Things that alert you should be heavy with context, like why are they alerting you? What do they mean? What do you do? All that other sort of stuff. I'm not going to go too much into detail on this. That's a whole different talk. It needs to be actionable. Are you just alerting someone to say, hey, by the way, stuff's slow? What am I supposed to do with this? Like, is there a reason? Actually, if it's that a customer is slow, that's important. Redis is slow. I don't care. Unless it's affecting the user, I don't care. It's not actionable. Symptom-based, not cause-based, right? We want to measure the things that the user cares about that are important to them, not just say Redis is busted. Unless Redis is breaking things, I don't want to know. Also, implicit to that symptom-based thing, actually, I think there's a whole slide about this. I shouldn't go through these individually. The important thing about the symptom-based stuff is that optimally you're building your systems to be somewhat resistant to failure, right? Like, if Redis is down, that's okay. We'll just use a stale version of it. Over time, you build these systems to be much more resilient to individual failure, but that also makes them weird and complicated on the inside. But that's why you monitor for symptoms, not causes. It didn't change. All right, so the goal is to notify about customer-facing things. The awareness stuff that you can give in context are things like how important is this service? Should it come back up? In disaster recovery, we call this return time objective, like how quickly do you need to get it back up again? Some features don't need to be brought back up quick, right? If it's a daily reporting tool, that's not that bad. People probably don't need it. Runbooks should help with mitigation actions. Most of the studies that pay attention to incidents come from the medical field, and the first thing that you do in a medical emergency is not try to figure out the cause of the problem. No, you stabilize the patient, stop the bleeding, apply the tourniquet, stuff like that, right? Same for incidents. How do we mitigate the problem? We're paying attention to symptoms here, not causes, and evaluate anything. This is the E in case, is you need to regularly evaluate that these things that you've set up to page you are there for a reason and that they're doing the right thing. You've probably made hundreds of these things. If you go look at the stuff that some of you probably have observability tools, and they're probably embarrassingly full of critical things that are actively not paging you, just sitting there being annoying. You should try to clean those up because they don't go anywhere. There's not a magical fairy that comes along and gives you a next funding round because they counted up how many critical alerts you had, right? At least I don't think so. It'd be a really weird VC firm. So we're going to talk briefly about building dashboards, right? How do we build dashboards out of all this stuff? In the same way that you need to only build alerting that's on things that are important to you, the same with dashboards. You can very easily have hundreds of dashboards and have no idea what any of them mean. So be thoughtful. Do not bury yourself in charts just because you have metrics to look at. Be sure to break out detail into other dashboards. There's a fellow by the name of Stephen Few who wrote a book called Digital Dashboard Information. I forget. Anyway, you'll see my blog at the end. I wrote some stuff about it recently. It specifically says a human can only keep 3 to 5 things in working memory at any given time. Dashboards are a sort of crutch. If you can see it all at once, you don't have to remember what that chart looked like and then scroll down the screen and then now look at this other chart. You can get all that in front of your face. But if they need detail and they've got to look at something else, flip it over to another dashboard. Build more dashboards with better information on them instead of one dashboard with a whole bunch of stuff that nobody can read. Organize these into groups by your teams, like who owns these dashboards. Smush them all together. Same for monitoring, right? If they own them, put them all together so that those teams can more easily find their stuff. Some tools are better at that than others. Also, I'm going to show some illustration of this. You need context in charts. they're called run charts, which is like time over a y-axis that's got a whole bunch of stuff on it. Time is important because that's how we think and we see the change, but time didn't break your stuff. That's not the causal part of a dashboard, right? The causal part are the changes that you made or that the users made. So we need to put that on there. So put the SLOs as a watermark, put deploys and feature flags and all that other stuff. All that needs to be part of what you put into your observability tools so that you can see it. And we'll illustrate that now with a terribly illustrated dashboard that will eventually happen. So this is probably the chart that you've got on something that you've built today. You've got some line going over time, blah, 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 right? This is fine, I can see this, but what does this mean? What is it supposed to look like? I have no idea, especially if it's a system I don't know very well and I didn't work on it the whole time and you just hired me yesterday. How am I supposed to understand this and understand its context? Compare that to this. Here I've told you that above here, that's bad. So maybe that's my SLO, right? And then steady state is the green line. That's what it's supposed to look like most of the time if everything's going well. We can see that on the far right, something's probably not great here. And then at the bottom, we've got deploys, changes, alerting, and stuff. This is based on the tool I work on, so it uses the same sort of things. But whatever it is, like highlighting the fact that change happened. The vast majority of the vast majority of problems that happen in our infrastructure happen because of a change. Somebody probably did something. It could have been a user, or it could have been you committing code 3 years ago that had a bug in it, but it's something that we do. There's a whole thermodynamics thing that systems just sort of degrade over time, but that's a different problem. We're not going to worry about that tonight. We can't fix thermodynamics. Not tonight. All right, so we've talked about a bunch of sort of like theory, and we've applied some of it in a very sort of like basic way to all of our services, but what are some more practical applications for ways that you can leverage observability additionally instead of just like monitoring and dashboards and tracing? So as I said earlier, this stuff is helpfully fractal, and fractal. Everything, so your product has SLOs, right? Like you've got some 99.99, how many nines? 5, 6 nines? No, probably not. Probably just 4. Anything more than that's silly, by the way, because my Wi-Fi is not that good at home. I'm not going to notice if you're down that much. Anyway, We'll talk about that too. So your product has SLOs, but so does every single thing in the stack that you've built. So if you're relying on a database that's only got 3 nines of uptime, but you're promising your customer 4 nines of uptime, that's not going to work because it's just math. You just basically take all the things and say like, well, we average a 99.95. That's the only thing we're going to be able to do. Actually, it's whatever the lowest one is, that's what your stack is going to have. So you can't promise something that pieces that you depend on don't offer. So you can do this though to your entire stack, right? All the way from, see that's the review these don't get stat blocked. That shouldn't have been in this slide. That should have been somewhere else. I didn't clean these slides up as good as I should have. Point being, you can do this everywhere in your stack, right? Everything from that one little instance that you run all the way up to the top line of the business and how many shoes you're selling. Who wants to start a shoe company after this? That's what we're going to do. So use the red method. That's what you should be doing when you build out your charts and measure your services. These are the things you should go for immediately. You should assume that anything that anybody builds is read and used, and all that stuff's taken care of. Again, we're paying attention to symptoms because causes are infinite. If you take nothing else from this talk tonight, please take away that causes are infinite, and monitoring for causes is a path to ruin. Monitor the red metrics. Pay attention to those. Those are the things that your customers care about, so you should too. Make a case for monitoring. See what I did there? And ruthlessly remove it. If you make something that pages people, like that deserves thought, and you should pay attention to it. Do not just page people without putting thought into it, right? Review it periodically and make sure that that's what it's doing. I don't think I've ever worked in an organization that does this well, and that's something that needs to get better, so hence why I made the case method. Use method is key for you on the workloads that you're generating, right? If you're trying to keep up with how well are we utilizing these resources and how do we scale them and how do we grow them, you need use to be able to sort of input into that. This is also really important for capacity planning. Somebody comes to you and says, hey, tomorrow this new customer is going to do this thing and send us buy a whole bunch of shoes from us or whatever. There's going to be a flash sale. I have stories about that too. There's going to be a flash sale. Can we handle it? You'll know if you have this. We know that systems don't exactly scale linearly, right? And that 1,000 requests doesn't mean that we all know that's true, but still, you will be much better armed than what you're doing otherwise, which is just a wild guess, right? I have no idea how many more slides there are. I've got about 8 minutes. So cost of goods sold, another important one. Money's a metric. Every single time somebody does a transaction, you can emit that as a floating point counter and just add them up. That's really convenient. Most providers that you're working with that you use for third parties also will give you their billing data. At Stripe, we took AWS billing data from the detailed billing reports, brought it in, and then shared it to all the teams internally with comparisons to their peer teams so that they'd understand what they were spending. Same goes for the vendor I work for now. All that stuff is available. We can bill individual teams, how many metrics they're using, which helps you keep track of things. You can also track reserved and spot instance usage. This is another thing we do. We'd say, hey, look, you're at about 80%. RI utilization, don't you want to get that to 95 because that's the standard at the company or what have you. These are all things that feed into your observability data and can be measured with most tools. Cost attribution is also pretty cool when it comes to tracing because let's say you've got a trace that works its way through your infrastructure and you know which things each of those spans came from, like they came from this instance, they talked to this database, they ran this query, they took this time. You also probably know how much those things cost. So if the EC2 instance costs this much per second and your transaction took this many seconds and it used these resources, you now know the cost of that individual request and you better understand your margin. And when it comes down to getting somebody to give you money, what do you need to do? You need to get that margin in the best place, and this is a great way for you to measure that and pay attention to it, since spans have all that data in them anyway. So we talked about micro benchmarks earlier. Observability stuff can help you with efficiency. If you're actually going to improve it, then you need to be able to prove that you have actually done it, right? So we need to validate that the change that we put into production actually did the thing and measure it in the long term. So you need to be doing this for all your systems. You also need this to check for regressions, memory usage, allocation rates, garbage collection. That's a great one to pay attention to, right? If you're using a language that has those sorts of things. Latency, staleness is another one. We often think about measuring system functions, but how stale data is also something that's very easily emitted as a gauge. So you can really easily keep track of that stuff. Also, an important thing about tracing is that it doesn't track some stuff like that, right? You can't get the depth of a queue, doesn't usually work well in a tracing function. So metrics still have a place. It's also important, we talked a little bit about mental models earlier. That's my sort of big deal right now is mental models and joint coordination. things I'm thought leadering a lot about. But the mental model stuff is really good. You need to keep the whole, as much of the org as possible needs to be on the same page with mental models, or else the org's not going to be able to work together. Things like dark reads and dark writes. Like if you're setting up a new system and you want to run it side by side dark for a while, you need to be able to use observability to measure how often or how successfully you're doing those things. Comparing instance types, like, oh, I'm just going to get this new instance, it's faster. But can you prove it? Can you demonstrate it? Garbage collection tuning I mentioned earlier. I talked about building systems that are resilient to failure. You do that by insulating them. So if you're going to start leveraging a couple of new dependencies, if you want to be able to protect the service from their failure, you may add fail fast. But how often are you failing fast? How often does your retry happen? How often does your circuit breaker flip? You're going to add rate limiting. Measuring timeouts in comparison and comparing them to performance is also really important. Fault injection is another good one. Chaos testing. Chaos testing's all the rage. If you were at the SRE conference, 3 weeks ago, a lot of chaos testing talk. Awesome stuff. Observability demonstrates what the chaos test is doing and helps you keep that mental model up to date. When you broke that service, did it reflect in all your observability tools and keep the mental model working the way that you expected it to? All right, next steps in review. Keep an eye on growth with observability tools. They will very quickly become expensive if you're not careful. It is an important investment and you should spend money on it, but you need to help teams understand what they're using so they can keep the cost in check. Emitting logs, emitting spans, emitting metrics, they are not free. They will add up very quickly, especially sort of late stage, right? They're sort of like super linear in some ways because people always add them, but they very rarely take them away. And so users, oh, I already said that. Sampling of logs and spans can help a ton, but it's a trade-off. Engineers really like deterministic systems where they say, I just did this query and now I want to go look and see if it shows up in my tracing tool. If it's a sample-based system, it's randomly choosing stuff, that can be really frustrating. Log sampling really pisses users off because they're like, well, it's not here. I just wanted to see if it was there. I don't want to have to run it again. Metrics can also be pre-aggregated, which can quite help costs. Like you can aggregate them up and only emit them every 10 seconds, 30 seconds, a minute. You can also consolidate counters. Sometimes you'll have or consolidate signals. Sometimes you'll have like a counter that measures something and then put a timer right after it. Timers always emit counters for free. That's just part of how they work in almost every system that does metrics. So cool little trick from an observability nerd. I have a bunch more. Talk to me. There we are. Okay, so what it is, I skipped the thing about control theory, but we talked about it briefly. It's an attribute of a system, not some coat of paint that you can just put on stuff. It's a measurement of what is happening in your stuff so that you can come back later and say, what's happening here, and then find that measurement and actually know. Very useful as an input for a lot of decisions you're going to have to make as you scale and grow. And it's applicable all the way from the top all the way to the bottom, because I said it was fractal earlier. Remember that. Oh, I thought it changed, but it didn't. You should care about it because it's going to make you more agile. Being able to ship faster because you're not being able to dig in and see why that change happened or have a better mental model so that you don't have to try 5 times. It ensures you know how and when to scale the things that you're using, keeps the mental model fresh, and allows you to validate hypotheses. These hypotheses are important all the way from, well, I think if we want to make it work this way, we just do this, all the way down to, oh my God, it's on fire, and I think if we do this, the fire will go out. It also helps you be prepared for fires. Okay. Parts, log, metrics, tracing. We build monitoring and dashboards to use. That's usually the outputs that we see. Logs, super easy to get started, but they top out pretty quick and get kind of complicated and need new ways to deal with them. But they're super, super good for ad hoc and post-mortem situations because logs always have all the dirt in them, right? Metrics are pretty vital for monitoring because most monitoring tools use them. Very efficient for known unknowns, but often sort of lack context because you got to know the name of the metric to be able to find it. Spans, fantastic context, and you can even decompose them into logs and metrics because what is a log line except a really crappy span? And they're a lot more work to set up because you have to thread them through all your infrastructure. Where to start? Be sure to design it into your stuff. You can't just slap it on. Establish a culture of measurement and validation where you use this stuff all the time, SLIs and SLOs. Take advantage of read and use and practice case for all your monitoring stuff. I think we're almost done. Then reap the rewards, right? It's magic now. We're going to see improvement in our incident detection times, your TTD, as it's often called, time to detect. And overall, your time to resolve an incident should also be better, because if you're able to peek into the tools and understand the problems, you should be able to more quickly resolve the problems. And if you're not, your incident management situation, like doing your postmortems and all that stuff, should feed back into your observability tooling to say, these are the improvements we need to make. Hopefully you'll be more efficient and have more objective outcomes in the things that you ship, and make sure you're shipping the right things. And you'll be able to focus on delivering value for your customers or your shareholders or your investors or whatever, and keep those important mental models fresh and be able to experiment more easily, because everybody sort of understands how the system works. And then iterate, because you're never ever done with this stuff. Just like you're never done building, you're also never done observing. So use case and evaluate all these things regularly and make sure that they're working for you. Plug your incident management stuff in. It's got to be a learning organization, right? Keep the stuff that helps. Get rid of the stuff that doesn't. You added the thing that paged you. You can take it out. It's not going to hurt anything. And then where you find yourself deficient through incident management, invest in that. In closing, again, the best tool is the one you've got. So don't feel FOMO, like, oh, we don't have tracing. That's okay. You can still get by. The more you invest in the tools, the better they perform. Someone told me yesterday, a friend of a friend was like, oh, this person, they're just really disenchanted with this tool now. And I was like, well, how much have they invested in learning from it? Because if you buy a fancy tool and you don't spend it, they're not magic. They're not just going to tell you what's wrong. The user is still very important. The operator is still very important. Mental models need to be checked. They get rusty. They get old. We have to pay attention to those. And observability is never complete. It has to grow with your complexity. If your system gets more complex and has more parts, so will your observability, just by definition, right? Because we've got to pay attention to it. I think that's the last slide. It is. Thank you. You can hit me up. I'm C. Watson at SignalFx. I'm GFAT on Twitter. I didn't put my website on here, which is onemogin.com, ONEMOGIN.com, which means one more time if you're from the South. It's not onemogin, which is what people usually think. And I guess I'm here for questions, and I'll be here for like another hour, and we can just talk stuff. But otherwise, have a good night, folks.
Observability as far as if they're just few Lambda functions, maybe a database.
Yep. So serverless stuff in general, most vendors now have tooling for serverless stuff, which is usually some sort of either library you import or a wrapper that you talk to. If you don't use a vendor to do it, then the common mechanism for getting things out of I'm answering the serverless question first, then I'll answer the depth question next. Usually if you don't do that, then like in a Lambda in AWS, you can often emit something into Kinesis or something like that to be able to measure it and then pick it up on the outside if you don't want to use a vendor solution. So there's ways both sides to get those. The question about depth is really good. I thought I had some stuff in here. I may have skipped a slide. The answer is unfortunately not Boolean for you. I don't have a figure to give you. My answer would be you invest as much as it is important. So if the thing that you are monitoring is, I read something the other day where someone said your observability spend should be 10 to 20% of your infrastructure spend, which I think is an interesting rule of thumb, but it was also someone who sells observability tools. So I don't disagree with it because I also sell them, but I think that it really depends upon how valuable that thing is to you and how many problems it's having. My general guidance on this is if the thing is working, you probably don't need to spend anything on it. Like it's getting by, it's having problems. But if it does start to have problems, the amount of problems multiplied by the amount of value that it has to you is probably the amount you should spend on observability. Because let's say that you've got an application that sells shoes and it sells 100 shoes a second, and you know what the average cost of a shoe is. You now know that how much revenue you're bringing in, right, from that thing. You know how much downtime costs you because it's some number of seconds of downtime times the value. That's a pretty good example of how much money you could save if you could bring down that TTD or that TTR. That's usually the guidance I would give, but I know I'm kind of just talking now, so I'm waiting for you to nod. Okay, he did this. I guess that's good. If that's not sufficient, then let's talk after. More questions? I will also talk at you for a long time if you ask them. Yay. I like questions. It means somebody was listening.
You mentioned that systems have to be designed for observability. What's a good way to do that? And maybe even if you don't have all the systems you might need in the future built out, what's a way to build them in a way that is good for
So A, how do you design something to be observable? And then B, how do you sort of make that repeatable so that you're not doing it from scratch every single time? I'm going to answer the second question first and the first question second. I think that made sense. So how do you make it a repeatable process? You do it with middleware, frameworks, libraries. The advice that I usually give if I were consulting and doing observability stuff is find the choke points in your infrastructure. So like, let's say for example, you, like the thing that I worked on, Stripe, the API at Stripe had a ton of middleware in it. And it was very easy for us to go in at the very top of that middleware stack and install some tracing stuff, and it just worked throughout the entire stack. It's kind of an 80-20 problem. Focus on the things that are going to get you 80% of the value and 20% of the, whatever. There's a law about that. Point being that if you can focus on those, that's good. But then secondly, do you have a way, like let's say that it depends on the size of the company. If you're relatively small, then get it cooked into that monolithic application you're building so that people just don't have to think about it. If it's common for your workloads to make calls out to Kafka, make sure that library is instrumented so that every time somebody uses it, they get that for free. The important bit about it is like, give people something and they will use it, right? Like don't use the stick to get people to instrument, use the carrot. So if you say, hey, if you use this framework to start that new service you're working on, it automatically comes with this SLI dashboard and all this other stuff. Like for example, that tracing dashboard I showed you is cooked into the product. So if someone adds tracing, they get that for free. They don't have to build a dashboard, they don't have to do anything. And that's like a really good way to get users to listen to you. How do you design something to be observable? Obviously, you know, the crap answer back is depends on the thing. But in many cases, if it's request response oriented, that's kind of easy, right? It's like when you handle the request, you emit a timer, blah, blah, blah. That's fairly straightforward. But what about state machines? And what about things that interact with queues? And how do tracing things interact with things that are asynchronous and take 3 hours to run? No good answers for those things. For state machines, it's usually about making sure that when state transitions happen, emit a metric at that time. And that's often a place where design comes into how the thing was built. One of the things I worked on a lot at Stripe were systems that were built to do batch processing in the middle of the night. And then they ran a transaction through a big series of steps. And the people that built the state machine built a good state machine, but they didn't build it to be instrumented. And so what they would commonly do is write systems that emitted a bunch of stuff by mutating databases and then write queries that periodically queried the database for invalid state. And that's not really a scalable way to do it, because you end up running almost more queries against it and bringing down your database trying to, it's easier to emit data at the time of state changes and then run metric queries over that to get it back out again. You have to stop and start to sort of think about things as how do I emit this as signals and make it like, you have to start thinking about edge triggering, level triggering, I don't know, engineering stuff, or like mechanical engineering and electrical engineering stuff. But the point being that the system has to be adapted to being measured, and that again makes a better design, I think, in the end. Just like a unit test, right? Because that code usually comes out better if you find a way. I know that's not a completely great answer, but there's not a good one. Sorry, I love you. More questions. Yeah, I like questions. We got all night.
Hey,
Hi.
I'm wondering, so let's say the span that you showed, like if it was, basically I'm curious about like sensitive customer data.
Mm-hmm.
So like if that was a order of Yeezys and you know they were ordering like
You jumped over the jump man.
Yeezys and it had like the customer's address, you know, how do you handle making the data logged anonymous?
Did I plant you? That's a really good question. I'm reminded of an incident where someone put API keys into tracing spans once. Don't. Usually with vendors, that's something that's in the contract that you say you will not do that. One of the things that's important when you talk to a vendor is ask them what happens, because many of these systems are not built to be mutable. And so when you say like, I need to delete a dimension off of a bunch of spans, that needs to be in the conversation that you have at the time you're talking with the vendor, because they need a plan and they have to have one, right? Like GDPR, HIPAA, there's lots of reasons that you have to pay attention to this. So the next thing is tokenize. So in Stripe at least, that's the entire business of Stripe, is basically giving you a token for a credit card. But there's also some weird stuff, like when you have a vendor, do you want, like, one of the things that we often struggle with at Stripe was, did I want to put dollar amounts into it? Because a lot of those dollar amounts could then be tied maybe to a customer. If you know the customer, maybe that's a publicly traded company and now you can count revenue. So we had a hard rule that you didn't put dollars into metrics. Same goes for spans though, because that stuff can leak out. So tokenize where you can, use IDs, and that's the cheap way, right? We've all got some primary key that we use to look this stuff up. Use that instead of the name. That kind of sucks because it makes it hard to look up, but we built it into our administrative tools so that when you went into the admin tool and like looked at customer X, then you could then click through into the observability tools and it made the jump for you into the token so that you could then find it. So that's another way, but also you just have to be diligent because your developers will find a way to put stuff in there. My favorite one of these is tax ID number for a business. That's not a big deal, right? Except if it's sole proprietorship, that's the sole proprietor's social security number. So don't log tax IDs. That happens a lot. But that's a place where it's going to happen. So either if you're setting it up DIY, you need to know how to solve that problem too, because it's gonna get out. It's just gonna. I wish it didn't. Would have saved me a lot of incidents if it didn't. These questions are so great. There should be more questions. Ask me questions about things that aren't observability. I don't care.
Where do you see observability tooling going beyond traces and metrics?
I think traces, metrics, and logs are pretty good. I think that the big thing that tracing gives us is not just the causality, but it gives us service awareness. And so we have, like, as vendors or as tools, we have an awareness of what is actually happening. Like metrics are all these anonymous, nameless things that you just put a name on and you emit them into a time series database and never look at them again. But tracing makes that, changes the game because now we understand how things are connected. This may be a question like, do you think we're going to have AI that tells us what's wrong with things? I am fundamentally not in the camp that machine learning is ever going, well, never is a strong word. In my lifetime, I don't expect that to happen. Every year, in every time I've ever worked in an observability team, some ML team came over and was like, hey, we can do this. There's a lot of fun stuff they can do. Seasonality, very easy to pick up. Correlation, if you think I once asked on Twitter, what is something you want out of an observability tool? And someone instantly replied correlation. And I instantly linked them to that website that shows that like the number of shoes Kevin Bacon owns strongly correlates to the number of deaths in paragliding accidents or something. Like correlation is not causality. So especially when you have thousands of metrics, that's not helpful. I think the thing, at least in sort of right now, a lot of this stuff is shaped by SREs. And a lot of SRE stuff is currently paying attention to what's called safety 2. So like safety in running big systems and how we think about this as humans. So like I'm focused right now at my company and pushing on like when an alert happens, what are we doing to help that person? Like what more information could we give them? And like when did this alert last fire and how many times has it fired and is it seasonal? And like I think that there's a lot more we can wring out of humans. Man, that sounds bad. I think we can do a lot more stuff to help humans be more effective at this. And I think a lot of our tools are sort of fundamentally bad at joint coordination, like getting people to work together. And I think that the tools will improve in that space. I think if they don't, someone will disrupt them. But the problem is that building a big tracing, logging metric tool is like fundamentally very expensive. And so it's hard, like, somebody's like, man, I'm gonna make an observability startup because this Cory guy's told me a bunch of great ideas. Good luck with building something that'll scale and ingest all that data. The incumbents have a big leg up on you. So, and I know you work at SignalFx, but still. Question in the back. Throw the microphone at him. Don't do that. Denise will yell at me if you do that. We had at one company I worked at, they had a cushy box, it was like squishy and plush, and it had a microphone in it, and they would actually throw it around the room. It was pretty cool.
Okay, so how would you deal with observability for the systems that do observability? Because like you mentioned, some of these things can grow pretty complex, right? So you have a monitoring system,
who watches the watchers, right?
And sharded databases, multiple front ends. Like,
yep.
Do you have any techniques to start sort of like what happens when that goes down, right?
So at the beginning, I thought you were asking about how to observe observability systems, but then the question got out of hand, and I'm not sure what it meant anymore.
Yeah, basically, how would you monitor your monitoring system? Like,
got it. Okay.
You go home and you're like, well, I'm not getting any alerts. I wonder if it's because
pay somebody else to do it is a good answer. But if you're not going to do that, move it outside of the infrastructure that you run everything else in first off. Keep the surface area as small as possible. So this is not a system where you want to be like, let's run stateful stuff on Kubernetes, woo! Like, don't do that. Keep it simple. Be as simple as possible in that stack. When you do pull it out and you get it to run in another place, a bunch of stuff like dead man switches. So if you're not familiar with this concept, it's basically the idea that if something doesn't like tick a box every once in a while, it starts to go off. So you have to get very creative. This is a really good question because it's like the stuff that only people that run observability systems think about. The place I work, we actually have a completely separate instance of what the customers use that just monitors our customers' version of that tool, right? We basically run 2 of them. It's sort of incurred in the cost of running the platform is that we have to run the platform against the platform. And it's, again, fractal. But at the end of the day, peel it out, make it as simple as possible, and build some good sort of like simple alarms around it to make sure that it's doing the basics. But that's one of the problems of running it yourself. You have to assume that if you use a vendor that they're going to do that for you, but otherwise, honestly, most of the companies that I've worked for haven't bothered.